The universe is vast, dark, and mostly empty, yet every now and then, it sends us a postcard. These are not written messages. They are cosmic travelers, objects hurled from the gravitational embrace of distant stars, journeying for millions, perhaps billions of years through the interstellar deep. When one of these wanderers crosses our path, it's a momentous occasion. It's like finding a message in a bottle drifting across an ocean of space-time, offering a tantalizing glimpse into a world utterly alien to our own. For astronomers and for all humanity, the arrival is a call to action, a chance to point our most powerful instruments at a pristine relic from another solar system. Are we alone? What are the other cosmic neighborhoods like? This year, on this very day, September 18th, 2025, we're at the center of such an event. A new visitor, designated 3I/Atlas, has entered our celestial backyard. It's only the third interstellar object ever detected. Its arrival ignited excitement, curiosity, and wild speculation. Its journey from a distant star system brings scientific data and a profound sense of connection to the galaxy. Our solar system is not an isolated island, it's part of a vast, interconnected cosmic archipelago. Debris from one star's formation can become another civilization's fascination. The story of 3I/Atlas is modern science at its most thrilling. A narrative unfolding in real time, powered by global collaboration and cutting-edge tech. This essay will take you on a journey to understand this visitor. The discovery unfolded quietly on a summer night, not with a sudden flash, but with the patient, methodical work of an automated sentinel. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS Observatory in Chile, a robotic telescope designed to scan the sky for potentially hazardous near-Earth objects, logged a faint, unfamiliar point of light. Initially, it appeared to be just another asteroid on a routine trajectory. However, as more observations were collected over the following days and weeks, astronomers began to calculate its orbit with greater precision. What they found was not routine at all. It was, in a word, extraordinary. The object was not moving in a closed elliptical path bound by the sun's gravity like every planet, asteroid, and comet native to our solar system. Instead, the object's trajectory was hyperbolic. This is a key geometric term that, in orbital mechanics, means one thing. The object is moving too fast to be captured by our sun. It was on a one-way trip, a cosmic slingshot that would carry it through our solar system and back out into the interstellar darkness from whence it came. This was the smoking gun. It confirmed that the object, soon given the official designation 3I/Atlas, was an interstellar visitor. The 3I in its name signifies its status as only the third such interstellar object ever confirmed, a rare and precious find that immediately placed it among the most compelling astronomical targets of the decade. Its speed, estimated at over 200,000 kilometers per hour, was a testament to its alien origins. Just as the scientific community geared up for a rigorous investigation, a different kind of narrative began to take shape in the public imagination, fueled by a prominent and provocative voice. Avi Loeb, a theoretical physicist, Harvard University director of the Galileo Project, is well known for his bold hypothesis that Oumuamua could have been an extraterrestrial artifact. With the arrival of 3I/Atlas, he once again proposed that we should remain open to the possibility of a technological origin. He pointed to the object's initial appearance, a point of light, no visible coma, no visible tail, and its unusual trajectory as potential anomalies that warranted a more radical explanation than just it's a comet. Loeb articulated his ideas in a scientific paper and a series of blog posts framing his proposal as an essential intellectual exercise. He argued that science progresses by testing all plausible hypotheses, even those that seem outlandish. He suggested that if 3I/Atlas continued its journey without showing any signs of outgassing, or if it performed an unexpected maneuver, it could be evidence of something artificial. A phrase that, while likely intended to stir intellectual debate, was tailor-made for sensational headlines around the world. The media naturally seized upon the most dramatic element of Loeb's proposition: aliens. As speculation about alien spacecraft filled the airwaves, NASA and the broader astronomical community were busy doing what they do best: gathering cold, hard data. The agency swiftly mobilized a coordinated campaign of observations, using a formidable array of instruments on the ground and in space. Leading the charge were the world's most powerful eyes on the sky, the Hubble Space Telescope and the James Webb Space Telescope. These observatories were pointed directly at 3I/Atlas, tasked with dissecting its light and uncovering its true nature. Their mission was clear: to replace speculation with evidence and to let the object itself tell its story through the language of physics and chemistry. The results began to pour in, and they were unambiguous. As 3I/Atlas drew closer to the Sun, its behavior changed exactly as astronomers would predict for a comet. The increasing solar radiation began to warm its icy surface, causing volatile materials to sublimate and burst forth into space. Soon, what was once a single point of light developed a fuzzy glowing halo known as a coma. Shortly thereafter, a faint but distinct tail began to stream away from the nucleus, pushed back by the solar wind and radiation pressure. Tom Statler, NASA's lead scientist for small bodies, summarized the findings with definitive clarity. It looks like a comet. It does comet things, and the evidence overwhelmingly points to it being a comet. The detailed observations went far beyond simply watching a tail grow. While NASA's findings conclusively ruled out an artificial origin, they simultaneously revealed that 3I/Atlas was far from an ordinary comet. The data collected by the James Webb Space Telescope painted a picture of an object with a distinct and scientifically valuable chemical personality. The most striking discovery was its unusual composition. Spectroscopic analysis showed a surprisingly high ratio of carbon dioxide to water in the gases sublimating from its nucleus. Carbon dioxide water. While comets in our own solar system contain both compounds, the dominance of carbon dioxide in 3I/Atlas suggested it formed in an extremely cold environment, likely much farther out from its parent star than our comets. This chemical fingerprint is a crucial clue about the comet's birthplace. Different molecules freeze at different temperatures, creating distinct snow lines in a developing planetary system. The high abundance of carbon dioxide ice indicates 3I/Atlas likely coalesced in a region of its protoplanetary disk where temperatures were frigid enough for carbon dioxide to freeze solid in large quantities, but perhaps not as rich in water ice as the nurseries of our own comets. By studying these chemical ratios, astronomers can begin to map the architecture of other solar systems, gaining insights into the distribution of materials and the conditions under which planets and smaller bodies form around other stars. In addition to its chemical makeup, the physical properties of the dust being shed by 3I/Atlas also held unique information. As sunlight scattered off the dust grains in its coma and tail, astronomers measured the light's polarization, the orientation of the light waves. This polarization signature was different from that of typical comets in our solar system, suggesting that the dust particles themselves had a different size, shape, or composition. These tiny grains are the fundamental building blocks of planets. The arrival of 3I/Atlas provides a crucial third data point in our nascent study of interstellar objects, allowing for the first time a meaningful comparison between these cosmic travelers. Before it, we had only two examples. Oumuamua, discovered in 2017, Borisov, found in 2019. Each was enigmatic in its own way, and 3I/Atlas adds a new layer of complexity and understanding. Oumuamua remains the most mysterious of the trio. It was small, reddish, and highly elongated. It showed no visible coma or outgassing. Yet it displayed a slight non-gravitational acceleration, a tiny push away from the sun that gravity couldn't explain. That anomaly led to speculation it could be an alien solar sail or probe. In stark contrast, Borisov was far more familiar. From discovery, it looked and acted like a typical long-period comet. It developed a prominent coma and tail. Its chemistry had high carbon monoxide but wasn't dramatically different. For astronomers, Borisov was reassuring. A baseline, it proved natural interstellar comets exist and can be detected. Now 3I/Atlas enters, carving a middle ground like Borisov. It's unambiguously a comet with coma and tail as it warms. That suggests Oumuamua's acceleration might be from outgassing like hydrogen. Hydrogen would have been invisible to our telescopes, not alien tech. Studying interstellar objects like 3I/Atlas is about more than just satisfying our curiosity. It is fundamental to understanding our own origins and our place in the universe. These objects are, in essence, galactic time capsules. They are pristine, frozen remnants from the birth of other solar systems carrying unaltered information across vast distances and immense timescales. Some analyses suggest that 3I/Atlas may have originated in the Milky Way's thick disk, making it potentially over 7 billion years old, a relic that predates the formation of our own sun and Earth. By studying its composition, we are looking back in time at the building blocks of a planetary system from a much earlier epoch of our galaxy's history. This is a revolutionary shift in astronomy. For centuries, our understanding of planetary formation was based on a single data point, our own solar system. We could study our planets, asteroids, and comets to piece together how they formed, but we could never be sure if our story was a universal one. Interstellar objects change that completely. They are direct physical samples from other experiments in planet building that have been running across the galaxy for billions of years. Each one we study allows us to test our models of planetary science against a new and independent example, refining our theories and expanding our vision of what is possible. The chemical information locked inside these comets is particularly valuable. The relative abundances of different ices tell a detailed story about the temperature and density conditions in the object's native protoplanetary disk: water, carbon dioxide, carbon monoxide. The story of 3IATLAS and the surrounding controversy serves as a perfect, real-world demonstration of the scientific method in its entirety. It showcases the delicate and often messy interplay between bold speculation and rigorous, evidence-based scrutiny. On one side you have the role of speculative thinking championed by figures like Avi Loeb. His proposal that the object could be an alien artifact, while highly improbable, forced the scientific community to consciously justify why they believed it was a natural object. This kind of intellectual pressure, even when it comes from the fringes, can be valuable. It ensures that mainstream conclusions are not just based on assumption but are built on a solid foundation of verifiable proof. This process of questioning assumptions is a vital engine of scientific progress. NASA's response to the alien claims embodies this principle perfectly. Instead of engaging in a war of words or opinions, the agency and its partners brought data to the conversation. Evidence is the ultimate arbiter. The journey of 3IATLAS through our solar system is more than just an astronomical event. It is a profound reminder of our evolving place in the cosmos. For millennia, humanity looked up at the stars. Today, we see a dynamic, interconnected galaxy, a place where the remnants of one star's creation drift for eons before gracing another sky. 3IATLAS is not the destination, another thrilling step on our endless journey of cosmic exploration.